Hello, this is Mr. Precella. I'm working some financial math problems using my TI-83 plus calculator. This is an interesting problem. It says find the monthly payment and estimate the remaining balance. So there's two parts. First of all, there's a 3-year computer loan for $3,023. 6% interest. So that's the first part. Calculate the payment. Then we want to know what's the remaining balance after 2 years. So let's see. It is a 3-year loan and it's monthly. So N is 3 times 12. There's 36 monthly payments. The interest rate is 6.3. The present value is the amount of the loan today, $3,023. At the end of the 3 years, we assume the future value is going to be 0. Better be. They paid it off. And there's 12 payments per year, and interest is being compounded 12 times a year. These two numbers will always agree. Alpha, enter or solve. So their monthly payment, notice how it says negative, but it's not, we don't enter it as negative. That just means you're paying it. That's what the calculator does. $92.38. Okay. And now it wants to know the remaining balance after 2 years. Well, okay. You'll use the same screen, but N will be after 2 years. So after you've made 24 payments, the interest rate is still 6.3. It started off at $3,023. You're paying $92.38 a month. We want to know Okay, I'm sorry. I had to pause it for a moment. I'm doing this at home, and my cat jumped up on this computer. I thought he was going to mess it up, but everything still seems to be correct. So anyway, where were we? We were trying to calculate the remaining balance after 2 years. So we've changed the 36 to 24. The interest rate is still 6.3. The loan started at $3,023. You're paying $92.38 every month. You see why you enter that as negative. This future value here should be less than $3,023, right? And so alpha, solve. So we're calculating what's the future value after 2 years. That's what it's asking. So $1,071.60. Notice how it's negative because you still owe that much. But do you punch in negative? No. $1,071. Oh, wait. It says round to the nearest dollar. I was about to round to the nearest cent, and it would have counted it wrong. So how should I round this to the nearest dollar? It's a 6 after the 1. So would y'all call that $1,072? Okay, let's see if the next problem is like this one. Okay, yeah. Oh, let me look back at that. So you paid for 2 years. Oh, well, forget it. I'm on the teacher side of things, so as soon as I punch it in, it's gone. But this is a good problem. It's a 30-year mortgage. We want to calculate the monthly payment and then how much is remaining after 12 years. That's going to be a good one. Okay, so let's go ahead and start here. 30-year mortgage, that means 30 times 12, 360 payments in a 30-year house loan. The interest rate is 3.42. The present value is the amount of the loan, $210,000. Now the payment, we don't know that. That's what we're going to calculate. But we know the future value. At the end of the 30 years, it better be $0. You better have paid off the house. There's 12 payments a year. Interest is calculated 12 times a year. So alpha, solve. Will this answer here on the calculator be positive or negative? Well, it's going to be negative because you're paying that amount, but we don't talk about negative payments. In real life, you say the house payment is $933, and would y'all call that 64 cents? The digit after the 4 is a 0, so definitely 64 cents. And now let's calculate how much do you have remaining of the $210,000 after 12 years. All you have to do to answer that one is change in from 360 to 144. After 12 years, you've made 144 monthly payments. Interest rate, the beginning balance. You now have the payment. Let's see. How much is remaining? $150,434.16. So after 12 years, again, it's negative on the calculator because you still owe that money, but you don't punch in negative. $150,434, and it says, oh wait, round to the nearest dollar. So the 16 cents, we'll just leave it at $434. Okay. Let's see. Is this the same type of problem? It's a 10-year student loan. Find the monthly balance and estimate the remaining balance after 5 years. Okay. So let me go up here. Just sort of ignore all these numbers as I type in the new numbers. It is a 10-year loan. So that's going to be 120 payments total. The interest rate, oops, what did I do wrong? It's not 1,200. 10-year times 12, 120 payments. The interest rate is 2.82. The present value is $28,800. Now, at the end of the 10 years, we want that balance to be 0. And now I'll calculate this new balance, alpha, solve. So the monthly payment here is $276. And since the digit after the 0 is a 5, we'll round that up, 11 cents. Okay. A lot of times on payments like that, banks will round up, doesn't matter what, any little small amount. But we're just using the traditional rules of rounding. Uh-oh, what did I do wrong? Let me see. 10 years. Oh, 2.82. Okay. But you'll notice they were I punched in 2.85. If there were a class out there watching me do this, someone would have called out. But it happens. So let's see. Alpha, enter. Now let's see, $275 and 0.708. Is that going to be 71 cents? Mm-hmm. It's okay to make that sort of mistake doing homework, but you got to be really careful on the test. Okay. And now the remaining balance, all I have to do is what? Change that in after 5 years. Let's see. 5 years would be 60 months. Let's calculate that future value now. It's no longer zero. It's zero after 10 years. You might be thinking, well, wait, it'll be half, 14,400, because you paid off half the, it's exactly half the number of minutes. But no, it isn't. It's like $1,000 more than half. Okay, so $15,412.33. Since we're rounding to the nearest dollar, we'll just say 412. Okay. Oh gosh. Hey, let's see. Find the monthly payment and estimate the remaining balance at the given time. Assume interest is on the unpaid balance. It's the same problem. Oh, a 20-year student loan for law school. So, okay. 20 times 12. The interest rate is 3.36. The amount of the student loan is $128,000. And at the end of the 20 years, we want that future value to be zero. Notice for monthly payments, it's always 12. Let's calculate our payment. I guess I need to be more careful and make sure I didn't mistype any of these numbers. So $733.17. So next time you're getting a car loan and stuff, you can tell them, I don't need you to tell me. I'll calculate it myself. Or you can check their math and see what they're getting. Now, what about the remaining balance after 8 years? So how much does this lawyer owe after 8 years? All you do is change in to 96. And now the future value is no longer zero. You haven't finished the loan. Alpha, enter. Okay, so after 8 years, this lawyer owes, it says round to the nearest dollar, $86,788.05, so, or 6 cents, so we'll just round it to $788. Oh, I love these problems. Aren't they fun? Especially when you don't have to deal too much with those formulas. It's not my intention that you be plugging every one of these into your formula. If it were, I'd have to assign fewer problems. Okay? Now here's an amortization table. And this is what you might get when you're buying a house, but it would have a lot more payments. But this is something with 12 payments. It's $3,500 loan. After the first payment, notice they've calculated the payments. On the first payment, $35 is interest. This is how much goes on the $3,500. And so here's your remaining balance. Let me see. What was the question on here? It said, use the amortization table to determine how much of the ninth payment is interest. So, there. I'm going to turn off this right now because Oh, wait. Oh, no. Let me see. Second off there. So all that number isn't there. How much of the ninth payment is interest? Here's the ninth payment. The first column is the payment. This next column is the interest. So on the ninth payment, $12.13 is interest. Here's the amount that's going on the loan. So $12.13. Now, let's see, here's another amortization. Use the amortization table to determine how much of the seventh payment is used to reduce the debt. Well, this is the amount that's going on the principal. That's what's used to reduce the debt. So on the seventh payment, $377.85 are used to reduce the debt. So $377.85. Let me punch this in. Okay. Use the amortization table to determine how much interest is paid in the first 4 months of the loan. Well, in the first 4 months, here's the interest, 1, 2, 3, 4. So let's just add that up. 15 plus 13.82 plus 12.62 plus 11.42. $52.86 is interest on the first 4 payments. Okay, so 52.86 okay. Oh, now this is a really interesting problem. Find the cash value of the following lottery jackpot. Yearly jackpot payments begin immediately. Okay, this is one of those times that when you're using the TVM calculator, you're going to have to put it on beginning, not end of the period. Assume the lottery can invest at the given interest rate. So this person won an $11 million jackpot. But instead of getting the 20 annual payments, what would the cash equivalent be? That's what it's asking. So let's open up our apps. My TI-83 Plus, I only have one app. Those of you with the 84, you'll have more stuff there. So how do we figure this out? Well, here we go. Open your TVM solver. Let me clear out these numbers. Let me pause for a second. Okay. I had to pause to try to clear off my calculator. And let's see. Okay, so we're trying to calculate the present value of $11 million lottery jackpot. Well, this is one of those times when they begin making the payments immediately. So you're going to put it on begin. Oops. Let me see this. Whoop. Enter. Okay. And I don't know how it got 1 and 12 there. These are annual payments, so it's just going to be 1 and 1. Let me go back up to the top and fill it out. 5% interest. No. Sorry. 20 annual payments. The interest rate is 5%. The present value, that's what we're trying to calculate. The payments are what we need. And that we're going to calculate right now very easily. If you win an $11 million jackpot to be paid over 20 annual payments, all they do is divide the $11 million by 20. So we're going to say negative because it's a payment. 11 million divided by 20. Okay. Now at the end of the 20 years, you've got all the payments. So the lottery company, the state, is paying you $550,000 a year. Okay, what would be the present value of getting $550,000 a year spread out over 20 years, once a year for 20 years? We go up to present value, alpha, solve, and let's see, what's that going to be? 7 million. They say round to the nearest dollar. 7,196,926 since it says round to the nearest dollar. So 7,196,926. Okay. Let's see. Oh, another one just like this. Here, a $47.2 million jackpot for 30 years. N is 30. What's that interest rate? 4.446. Present value is what we don't know. I'm going to put a 0 there just to clear out all those numbers. But what about the payments? Well, it's going to be negative 47,200,000. Let's see, so 47 million, then a 2 with 5 zeros. 1, 2, 3. Divided by 30, because there's 30 payments. At the end of the 30 years, 0, 1, 1, beginning. Okay. So let's go up. So here's how much you're getting a year. $1,573.33. And let's calculate that present value. Alpha, enter. So what's that present value? 26,938,155.43. Since we're rounding to the nearest dollar, I'll just say $155. Okay. Problem 18. Benjamin Fritz buys a car costing $22,000. He agrees to make payments at the end of each month for 4 years. He pays 4.8% interest compounded monthly. What's the amount of each payment? So that's the first thing we're going to do. So let's see if it's 4 years monthly. 4 times 12. The interest rate is 4.8. The present value, the amount of the car loan, is $22,200. The payment, we don't know that. That's what we're going to try to calculate. We know that at the end of the 4 years, we want the future value to be 0. But be careful down here. You got to go 12, 12, and it's now at the beginning. The end. And even if you're thinking, well, wait, I'll make my car payment, it's due at the first of each month. You own the car for 1 month. At the end of the first month, you make a payment. Okay? So let's calculate that payment. Alpha, enter. So the monthly car payment, rounding to the nearest cent, don't put the negative, $509.24. Now, let's see. Find the total amount of interest Fritz will pay. So he's making a car payment of $509.24 every month for 4 years. So for 48 payments. So to answer this, you don't need the TVM solver. It's just multiply and subtract. 509.24. That's his monthly payment for 48 payments. So he's going to pay a total of $24,443.52 over those 4 years. But the cost of the car was $22,200. So you say that $24,443.52 minus $22,200 gets you $2,243.52. That's how much interest he paid. Y'all follow my logic? If this is the total amount of money he paid on the car, paid on the loan, and here's how much the car cost, anything over $22,200 has to be interest. Now, let's see. On we go. A student borrows $45,900 at 10.8% compounded monthly. Find the monthly payment and the total interest paid over a 15-year payment plan. Oh, same type of problem. So let's go to our, first I'll clear that. Then we'll open our financial apps and TVM. Okay, so it's a $45,900 loan, 15 years. So N is going to be 15 times 12. That means making 180 payments. 10.8 is the interest rate. The amount of the loan is $45,900. Find the monthly payment. Let's see, these are monthly. Future value 0. Monthly payment, I'm going to calculate it. $515, and is that 0.948 or 0.940? That's 8. So would y'all call that 95 cents? $515.95. So this person is paying $515.95 a month for 15 years. How much interest did they pay on that $45,900 loan? Now this might be a little shocking. $515.95, paying it per month for 15 years. I'm going times 12 times 15. If you just want to go times 180, that's how much they paid. $92,871 is how much they paid on this $45,900. So they paid a little bit more than twice the loan amount, if I'm correct. So let's see, how much is the interest? It's more than the loan amount. Yeah, $46,971 in interest on the $45,900 loan. Okay. Oh, wow, that's the last one. Well, then, thank you for watching, and I sure hope you're enjoying this financial math as much as I am. It's really not my intention that you bog yourself down with the formulas. If you want to do it with the formulas, okay. Here's, let me move the calculator. You can look at the formulas, see how to do it. They use the present value formula. Okay, but I really think that you lose what you're actually doing if you spend too much time plugging into formulas. This really isn't a plug into formulas course. It's a financial application of math course. If you can read these problems and understand it, be able to punch it into a calculator like this, then you are doing great. That's what the course is intended for. So thank you for watching, and bye-bye.